First thing we're going to talk about is algebraic methods. Produce more accurate methods than geometric methods. So even though on the bell work I was using a ruler and I was making sure that everything was nice and straight, what you'll also notice about those is there were no decimals in the original movements. It was a 5 by 4, right? We didn't have 5.2 movement. And so when you think about real life movement, it's probably not going to be beautiful integers that things are moving at, right? And so geometric methods are great to initially start off and get a picture in your mind as to what is happening when we talk about different movements. But algebraic methods are going to be a lot more accurate, all right? And so one of the algebraic methods is trigonometry. So solving triangles requires some basic knowledge of trigonometry. And honestly, in the physics section here, the trig that we use is going to be pretty basic SOHCAHTOA type trig, all right? But it requires trigonometry, which is the study of triangles, right? Trigonometry, all right? And so we're going to be solving triangles. So this whole section is just really reviewing what that means. What does this mean for solving triangles? All right, so what do we mean by similar triangles? This is really important in trig, is that similar triangles have equal angles. You'll notice on this that 37, 37, 53, 53, and of course 90, 90. The angles are equal when we have similar triangles. However, when it comes to the sides, those are proportional. So the sides create proportional fractions or ratios. So the angles are equal, the sides are proportional when we're talking about similar triangles. All right, so let's talk about just some of the basics that we should know. The sum of all the angles in a triangle add up to what? 180. In a right triangle, the two acute angles then should add up to 90. And as we have already been using, we will also again be using the Pythagorean theorem. That's actually a squared. It just didn't let me put it as a superscript. So it should look more like this. A squared plus b squared equals c squared. And so in this triangle that we've been given, we have our two legs of it. Those are what we're squaring. Will equal the square of the hypotenuse. That means angle alpha and angle beta will add up to 90 degrees because they are my acute angles there. Side proportionality. Ratios of corresponding sides are always equal. Ratios. So that means that if I set up a fraction, 5 over 7.5 will equal 4 over 6, which will equal, I screwed him up, 3 over 4.5. All right. So they create the same ratio between the sides. All right. The next thing, which should be very, very familiar to some of you, is trigonometric ratios. My sine is opposite over hypotenuse. My cosine is adjacent over hypotenuse, and my tangent is opposite over adjacent. SOHCAHTOA is how we remember it. Now, keep in mind, when I am putting in opposite and adjacent, it is relative to the angle I am talking about. Hypotenuse is not. Hypotenuse is always opposite my right angle. So my hypotenuse is always going to be, find that right angle, and the guy that is across from him, that is my hypotenuse. It is across from my right angle. It is my longest side. But when I say the word opposite or when I say the word adjacent, that is when you have to look at what angle am I talking about. So if I'm looking at this particular triangle, they show me the sine of alpha. Well, I need to go to that alpha angle and I need to label that triangle based just on alpha. So if I'm looking at alpha, the opposite side is A. So my sine of alpha is going to be A over C, opposite over hypotenuse. However, if I go to beta, that's going to be different. For beta, my opposite side is b. And so the sine of beta is going to be b over c. Cosine, again, look at the angle you're talking about. Adjacent to alpha is this b side. So my cosine's b over c. Tangent, again, opposite over adjacent. I have to look and see what angle am I talking about. So how does this help us? Well, the first way it helps us is if I have similar triangles. This is basics like Algebra 1 basics. If I have similar triangles, I can set up ratios and I can solve them. I don't even actually need trig to do this. I can do basic solving ratios. So you can say, well, x over 7.05 should equal 1.85 over 2.14. I'm literally setting up equivalent fractions. How do I solve ratios? Way back from Algebra 1, how do I solve those? What's the method for solving equal ratios? So if I wanted to solve this, I can cross multiply. I can say 2.14 times x equals 1.85 times 7.05. And I can solve and get the height of that flagpole. All right. I know all the basics of this. They have given me one side length here. All right, so they've given me 8.2. They've given me one angle, 17 degrees, and they've given me, we automatically know this angle is 90 degrees. All right, so the easiest thing to solve for here is the other angle. If I know that beta is 17 degrees, then if I want to solve for alpha, I should just be able to say 90 minus 17 degrees. All right, they are complementary angles. They add up to 90. So what is my angle measure for alpha? What's my angle measure for alpha? (73 degrees). So now I know all of my angle measures, 73 degrees. All right. I need to solve for my sides. So we're going to use trig to do this. All right. If I want to solve for, let's say C. C is probably the easiest. We're going to use alpha to do it. Based on alpha, let's label my triangle. If this is alpha right here, which side is 8.2? Opposite, adjacent, or hypotenuse, if I'm talking about the alpha angle right there. Opposite, adjacent, that's opposite, all right? Which means B is going to be adjacent and C is going to be hypotenuse. I want to solve for my adjacent side, all right? I want to solve for my adjacent side. I want to solve for my hypotenuse, all right? If I had two of those sides, I could use Pythagorean theorem. I don't, so I'm going to use a trig function. Which trig function can I use if I want to use, let's say, the alpha angle? Depends on which one I want to solve for. Let's say I want to solve for adjacent. What trig function deals with opposite and adjacent? Tangent. So the tangent, we're solving for B. The tangent of 73 degrees should equal my opposite side over my adjacent side. How do I solve for that? In your calculator, what are you going to do?
Tangent of 73 times 8.2.
Right, so then divide across. So B is going to equal 8.2 divided by the tangent of 73 degrees. A couple things here. Your calculator has two modes. It has degree and radians. We are in degree. So you want to make sure you check it. Click on the mode and make sure that it says you are in degrees. Because if you are not, if you're in radians, you're going to get the wrong answer. So go ahead and calculate it. Calculate your length of B. What is the length of B? 2.5. 2.5. All right. A couple things. If you're trying to get very exact, like let's say they wanted out multiple decimal places, you may not want to use Pythagorean theorem here. We haven't rounded too much, so you're probably fine. two ways to solve for that third side. We now have two of our sides of a right triangle. You could use a squared plus b squared equals c squared, right? Or, so here you could say, well, a squared plus b squared should equal c squared, all right? If you want to be more exact and say, well, I rounded b already in the process, you could go back to your trig function and use opposite hypotenuse. You could say, well, the sine of 73 degrees should equal the opposite over the hypotenuse and do exactly the same thing. All right, so either way, calculate your length of C. It says solve the triangle. You should have all three angle measures and all three side length measures. All right, typically when I solve them, I'll actually write it out. I'll say like angle A, angle B, angle C, and then I'll say side length A, side length B, and side length C. I will fill in what they gave me. Obviously, I know that's always 90. And then I will go back and put in what I solved for. So 73 degrees for that, 2.5 for that, 8.6 for that. And that's how I verify that I solved all three sides and all three angles. That's what solving a triangle means, to get all three of each. So when we solve triangles, given two sides of a right triangle, we can find the measure of its acute angles. Inverse trig operators then. So again, you have your sine, cosine, and tangent. That's when you have the angle and you are solving for that ratio. When you're using inverse trig operators, you have the ratio and you are solving back to see what the angle is. All right, so you have the ratio of the appropriate sides. You are getting the angle versus putting the angle in and getting the ratio. All right, so that's what it means by inverse. Inverse is what you're going to use when you are solving for the angle measure. You're going to use the original functions when you are solving for the ratio. All right. So now they're asking us to solve for this angle. And the last time we solved for an angle, we just did it by subtracting from 90. But you'll notice I don't have any of the two acute angles here. If I had had one of them, I would have just subtracted. I don't have either. So I'm going to look at the two sides that I have. Again, you're going to do the same process. You're going to say, I'm talking about this alpha angle here. What two sides do I have based on the fact that I'm looking at the alpha angle? What is 7? Opposite. What is 8? Adjacent. Which trig function deals with opposite and adjacent? Tangent. So I'm going to say the tangent, I don't have the angle, I have the ratio, so I'm going to use the inverse tangent of 7 opposite over adjacent. In your calculators, you're going to have to use your second button, the function that you're talking about, which in this case is tangent. It's going to open parentheses, and there you're going to say 7 divided by 8. And then it will give you an angle measure. You should have gotten approximately 41.2 degrees for that angle measure, all right? If you just do 7 divided by 8 in your calculator, you're going to get 0.875. That is the ratio between an opposite and an adjacent side for every angle that measures 41.2 degrees, all right? So whether it is an angle that fits on my paper or whether it is an angle that's, from a satellite dish to Earth, 41.2 degrees will give me that same ratio between those two sides. Okay? So if it says specifically find a side, you're going to use your trig function. If it says find an angle, you're going to use your inverse trig function. If it says solve the triangle, you're going to have to do whatever you need to do to solve for the triangle. In this case, if I'm solving a triangle, then I want to make sure that I know angle A, angle B, angle C, side length A, and I'm just going to label them opposite like that. Side length B, side length C. I'm going to fill in what they gave me. And then I'm going to solve for my missing measurements. So go ahead and solve that triangle. Finish it out.